one more time. So we were given a function. I didn't graph the function. I just gave an example like we always looked at. So these are the 2 points. X equals 3. This must be f of 3. X equals 5. This must be f of 5. In order to determine the slope of this line, I have to write the rise over run. F of 3 minus f of 5 over 5 minus 3. F of 5 minus f of 3 over 5 minus 3. So f of 5, I have to plug it in. So I have 25 halves plus 5 fourths. F of 3, I have to plug it in. 9 halves plus 3 fourths. I was too lazy to calculate these, which I should have. Instead, because I noticed that they have the same denominator, I said, okay, let me put them in here. Subtract f of 3, meaning I have to distribute negative sign to both terms, and see what happens. And this looked really nice, because 25 minus 9 is 16, and 16 divided by 2 is 8. 5 fourths minus 3 fourths is 2 over 4, which is 1/2. Instead of continuing here and finding these, which we should have. It doesn't matter, really. So then when I add, remember, I need the least common denominator. 16 plus 1 is 17 halves, and then multiply by 1/2, and that's the average rate of change. Let's look at a word problem before we continue with a difference quotient. So let's take a look. Now let's look at a word problem. Okay, would you like to look at the total cost? Would you like to take a look at the total revenue? Okay, let's say, which one?
Total revenue.
Total revenue, very good, awesome, 52. So I'm going to copy. They're giving us r of x, which is negative 0.001 x squared plus 150x. And they're asking us from the sale of X iPod holders, okay, is given by this. And they're asking us to find this. So they want R of 305 minus R of 300 divided by 305 minus 300. Can anyone tell us what this represents? Anyone? Can anyone tell us what this ratio represents? I'll stop sharing. What does this ratio represent? What is the meaning of this?
The rate of change?
Exactly, the average rate of change between these 2 points. In this case, we have R of 305, 305 comma R of 305, and the point 300 comma R of 300. Exactly. Excellent. So I know the denominator is 5, but I need to determine these. And of course, I'm not going to do this by hand. I already plugged in the function, and with second and table, I will plug in 305, and then I will plug in 300. Always go, although it's very clear, but highlight to make sure, oh, it wasn't clear. Okay, so I have to copy 45656.98 because we're talking about dollars, 2 decimal digits, and minus 44910. Okay, so let's go back for a second. So remember what this is. So R is measured in dollars, and X is the number of units. In order to make sure we understand that, R in dollars, X in number of units. Okay, so we divide, we subtract and then divide. So lazy people like me use a calculator. 45656 minus 44910, because I want to divide by 5 at the same time, and the answer is 149.40. All this calculation even a 5-year-old can do, but what a 5-year-old will not be able to do is to give us the measurement unit. What does 149.40 represent? What is the measurement unit? We know that this is average rate of change. Exactly between or on the interval 300 and 305, exactly this. But what is the measurement unit? Remember, this is an average rate of change. It has to have 2 measurement units, one coming from the top and one coming from the denominator. So what is the measurement unit?
Can we see the graph again?
Yes, I have it here. R, that's why I wrote it. R is in dollars, X number of units.
Dollars per unit?
Exactly. The measurement unit for the top is dollars. The measurement unit for the bottom is units. So that's what it is. The average rate of change is $149.40 per unit, which means from producing and selling 300 to 301, I'm getting a revenue of $149.40 per that unit. From 301 to 302, I'm getting $149.40 for that second unit. From 302 to 303, and so on and so forth. For each unit, I get a revenue of $149.40. Very good. 1.4. I don't have anything else to say. Now, in 1.4, let me refresh your memory on the difference quotient. Anyone remembers the difference quotient? What is the formula for the difference quotient?
F of x plus
A little bit,
h
yes.
minus f of x
Excellent. Over
divided
h.
by h.
Thank you so much. Awesome. So this is indeed the difference quotient. And remember, there are two things that have to happen, right? In the numerator, terms without age cancel out. And what is the second step that has to happen? And exactly in this order. Anyone remembers? For any function, when we calculated this, the terms without age at the top canceled out. And then what is the second step? Age in the denominator, this one, simplifies. Okay. So this is a major concept that we looked at. What is the other major concept that we looked at this semester so far? This is big. Why is it big? Because if you remember, we had P, we had Q, but they were so close to each other, I had to zoom in order to explain what I'm doing. But Q really is right here. So we determined the average rate of change, and all of a sudden we brought Q close by, and we said we are really interested in the slope of the tangent because that gives the instantaneous rate of change. So this one, PQ, the slope PQ, gives the average rate of change. But the slope of the tangent at P gives the instantaneous. rate of change. So what big concept we looked at in order to bring Q closer and closer, closer and closer, closer and closer to P? What is that big concept that we discussed over and over, over and over? Anyone? The concept of the limit. Thank you very much. So, excellent. These were the major topics. So 2 major concepts. Very good. One is the difference quotient, and the other one is the concept of the limit. Brilliant. Now we want to put these together. Give the so-called derivative function. You can say, what are you talking about? And I will explain. Okay, so let's look at 3 graphs. Here's one graph of a function. Is this function continuous everywhere?
No.
No, not continuous at this point, which is a jump, discontinuity. Or any other discontinuity. It could be, or it could be something like this with an infinite. But it's discontinuous, that's all I mean. This is graph number 1. Graph number 2, when the function is not continuous. Graph number 2. This is called like a cusp, right? Like between 2 teeth. Graph number 3. This is a corner. The last one, graph number 4. I'm going to use a different color for this one, just because I want to show something. At this point, this graph has a vertical tangent. So, first of all, I did not show what this means. That's my next step. I want to show you these graphs, so talk about these graphs for a moment, and then I'll show you what that means, because I didn't show it. I'm going to put the limit operator in front of the difference quotient, and we are going to create this function. But before that, we need some preliminaries. Okay. A function that is discontinuous, has a jump or infinite discontinuity, or even removable, does not have at this point a unique tangent. What does that mean? Well, so here's the tangent here with some slope, and here's the tangent on this side. Not a unique tangent. And you can say, who cares? Well, all we are saying is that at this point for x equals 5, let's say, if you ask me, find the rate of change of this function at 5, I'll say, I'm sorry, I can't have it. I can't give it to you. It doesn't exist. If you ask me, find the rate of change of this function here, I will somehow determine the slope of this tangent and I'll give it to you. It may not be exact, but I'll be able to give it to you. If you ask me, give me the instantaneous rate of change, in other words, the slope of the tangent line at this point, I'll say it exists. I think is something like 3 over 3 or 1 over 1. I'll give it to you. But if you say, give me the rate of change at 5, I'll say, sorry, I can't. Because there is no unique tangent. Good. Here, same problem. It's a vertical tangent. A tangent that is vertical in this case has a slope that is infinite. Slope of a vertical line is infinite. Here I can give you is 1. Here I can give you is 2. But here I'll say, I'm sorry, I can't. The slope of this line, in other words, the instantaneous rate of change at this point does not exist. Because the limit that is infinite does not exist. Then you're asking me for, let's say, to give you a rate of change at 4. I say, sorry, I can't. How come? Well, I don't know which one to give you. This is positive slope, and this is negative slope. I can't. It's not unique. Not a unique tangent. I can't give you a rate of change at 4. It doesn't exist. If you ask me, what about here? Yes. Yes, the function there is continuous and it has 1 tangent. What about here? Yes, it's continuous and it has only 1 tangent. I will give it to you. But here I'll say it's continuous, but I cannot give you a tangent. The tangent doesn't
I have a
exist.
question.
Yes?
But couldn't you say that at 4, you could make like a tangent slope, an instantaneous one, right?